friends, welcome to lecture 5 of games theory. In this lecture, we'll discuss graphical method. Now, sometimes it is not possible to solve by the algebraic method because the matrix, the payoff matrix being more than 2 by 2 and there is no saddle point and you cannot reduce the payoff matrix further. Now, if it is 2 by 3 and 3 by 2, you can solve it by subgames method. However, if it is more than that, it is not possible to solve by subgames method. So in such cases, if the matrix is 2 by n or n by 2, if the payoff matrix is 2 by n or n by 2, then we can solve it by graphical method. Only then, otherwise not. If it is 3 by 3, then it's not possible. If it is a 4 by 3, not possible. If it is 2 by 4 or 2 by 3 or 2 by 5 or 5 by 2 or 6 by 2, then it is solvable by this graphical method. So how to solve by graphical method, that we'll be discussing in this particular lecture. So this is the problem that we are going to solve. Let us assume that there is no saddle point in this game and you cannot reduce it by rule of dominance. So this is a mixed strategy game having a probability P1, P2 respectively for strategies A strategies 1 and 2 and Q1, Q2, Q3 for B strategy 1, 2, 3 and 4 respectively. Now, although in this particular problem I think 2, 4 is dominated by 2, 3 and you can eliminate this strategy, you will see that this strategy is inconsequential in the graphical method. But anyway, for the sake of learning, let us say this is not cannot reduce the matrix further by the rule of dominance. So this does not have a saddle point. So we will be using graphical method to solve the problem. Now how to solve it by graphical method? Now for B's pure strategy 1, the expected payoff is this one for A. Similarly for this, the 4 equations can be written like this. We'll be plotting these 4 equations in a graph paper. Now let's say B has 2 strategies. This axis represents B strategy 1 and this axis represents this axis represents A strategy 1 and this axis represents B strategy 2. That basically means that P1 is 1 for this line and P1 is 0 for this line and P2 is 1 for this line and P2 is 0 for this line. Okay, so this is A's first strategy and this is A's second strategy. Now we'll plot the B's strategy in this graph paper. Now I have divided this into 24 segments, as you can see. Into 24 segments I have divided it. So if you move from here, this is the fourth one, 1, 2, 3, 4. 4 by 24 is 1 by 6. So like this, it is how much? 4, 5, 6, 7, 8. 8 by 24 is 1 by 23. So these are all P1. P1 is 1 by 6 here, 1 by 3, 1 by 2. P1 is 2 by 3 here. P1 is 5 by 6 here. P1 is 6 by 6, that is 1 here. So these are values of P1. Similarly, you can write the values of P2. P2 will be here 1 by 6, 1 by 3, half, 2 by 3, 5 by 6 and P2 equal to 1 here. Now if I take the first equation for B's pure strategy 1, the first equation will be 2P1 plus 4P2. Now if P2 is 0, if P2 is 0 here, then this is P1 is 2 here. And similarly, if P1 is 0, this is 4 here. So we'll plot the graph like this. Okay. So P1 1, P2 0, P1 0, P2 1. So this is the value, we'll join it. We get this plot. Similarly for B strategy 2, A's expected payoff is this one. So this is the A's expected payoff. 3P1, 2P2. 3P1, 2P2. Okay. And the fourth one minus 2 P1, so minus 2 P1, 6 P2, 6 P2. Okay, now here we are interested in finding out the maximum of the minimum. A's point of view, we are trying to find out. We are trying to find out what is the values of P1 and P2. So A, being an intelligent player, knows that B is also an intelligent player, and A has to select the minimum maximum of the minimum losses. So A is a maximum player. So the maximum losses is represented by the lower bound of the graph. So this is the maximum losses and this is the maximum profit. Okay, so this area represents the minimum losses. So this represents the minimum losses of minimum profit of A. This represents the minimum profit. I'm extremely sorry. This represents the minimum profit of A, and out of this minimum, A wants to maximize it. So this is the maximum point. So we have to see the lower bound. We have to see the lower bound. So this is the lower bound, and the maximum of the lower bound is this point. So this is maxi-min point. I repeat, A is a maxi-min player. That means A tries to maximize his minimum losses, minimum gain. So this is his minimum gain. I repeat, this is his minimum gain, and therefore the maximum of the minimum is this point. So this point is the maxi-min point. So from here, if I drop a perpendicular here, this value will give you the value of P1 and P2. Okay, so from this we can find out P1 and P2. Once we find out P1 and P2, we can find out the value of the game from any of the four equations. So here, so P1 is equal to half, or what you can do is that you can see the maxima lies between the two equation number 3 and equation number 4 here. So you can find out the solution. The solution of the game will be the solution of the 3 and 4. So therefore, and you can see here this 2-4 strategy, the first equation, A will never play the strategy 1. Okay, so it will automatically be eliminated by rule of dominance. But anyway, here, so the solution of the game lies in the solution of equation 3 and 4. So here, solution of the equation 3 and 4 is here. You can find out P1 and P2 by solving for equation 3 and equation 4. Okay, now to find out P1 and P2, here you can to find out the value of the game. You will be putting the value of P1 and P2 in equation 3 and equation 4, and you will find out the value of the game. It comes out to be 22/9. I repeat, to find out the value of the game, you will use the value of P1 and P2 in equation 3 and equation 4 only. Now let's consider this. Here A has more options and B has less options. So A has 3 strategies and B has 2 strategies. So there is no saddle point and you cannot reduce this matrix. And these are the B's expected payoffs for each of the pure strategies played by A. So this is represents B1 and this represents B strategy 2. That means this is Q1 equal to 1, and this is Q1 equal to 0, this is Q2 is equal to 0, and this is Q2 is equal to 1, because okay, now accordingly these are the values of Q1 at this particular points. So for each of these equations, the 3 equations, we will be plotting it. So first equations, if Q1 is equal to 1 and Q2 is equal to 0, we get -2, and this is equal to 0 and this is equal to 1, and get equal to 4. So joining these two, we get this equation. Okay, Now next equation, 8q1 plus 3q2, like this. Now here, now I am interested in finding out the probabilities of q1 and q2. To find out the probabilities of q1 and q2, that means which strategy B is expected to play. Now B being an intelligent player, he knows that A is also an intelligent player, and A will play in such a manner that B's loss is maximized. So B will play in such a way so as to minimize his maximum losses. So his maximum losses will be represented by the upper bound of the solution. So this is the upper bound of the solution. Okay, this is the upper bound of the solution, and here the minimum of that is this point. The minimum of the upper bound is this point. So this is the A's B's minimum loss. So from here you can find out q1 and q2, or you know this lies at the intersection of this equation and this equation. Okay, so this is basically equation 1 and equation 3. So if you solve for equation 1 and equation 3, you can find out the values of q1 and q2, which comes out to be 0.09 and 0.91, and putting this value in either in equation 1 and equation 3, you get the value of the game, that is 3.4 units. Remember, if you by mistake put the values in the equation 2, then you will not get this value of the game. So very clear. I have often seen students repeating the same mistake, finding out the q1 and q2 and putting it in the wrong equation and finding out the value of the game, so getting it all wrong. So this is the graphical method of solving game. Okay, so solve more problems, then the concepts will get clear to you. Thank you for watching this video. I hope you have liked it.